Start.
Good morning. I am Binu from Kerala. Here I would like to present one of my research paper titled as Weighted Similarity Measure and Decision Making in Clinical Application of Neutrosophic Subset. The main objective of this paper is to develop a decision model in radiotherapy treatment for movable organs. The contents include introduction, normalized orthogonal distance, decision making using weighted similarity measure. Next, reference. Start with a simple definition, Neutrosophic set. Let X be a universal set. Then every element of a set is characterized by three components. We call it as T, I and F. T represents the membership of truth. I is indeterminacy, F is falsity. These three are functions from x to -0 and 1 plus. These are non-standard interval. If these three are functions x from closed interval 0, 1, then A is known as single valued Neutrosophic set. Then next, A and B are two Neutrosophic set. Then A is contained in B, denoted as A is subset of B, if and only if A of x less than or equal to B of x for all x belongs to x. This means T A of x less than or equal to T B of x, I A of x less than or equal to I B of x, F A of x greater than or equal to F B of x. Then the complement of a Neutrosophic set is we reverse or interchange the components. That is F A of x 1 minus I A of x T A of x. Next, the soft set. Actually, the soft set is a parameterized family of subset of x. Let x be an initial universe of objects and E be the set of parameters. Then a pair FA is called soft set. That is, FA is equal to set of E, F of A, where F is a function from A to power of x or subset collection of subset of x. Next, example of a subset. Let x equal to set x1, x2, x3, x4 be the universal set which contains 4 houses under consideration by an agent, and it is characterized by 3 parameters. E is equal to cottage, E2 is equal to mansion, E3 is terraced. A customer to select a house from the agent, he can construct a soft set FA that describe the characteristics of house. That means FA is equal to E1 set x1, x2, E2, x3 and E3, x3 and x4. Then what do you mean by the Neutrosophic subset? Neutrosophic subset is the combination of Neutrosophic set and a subset. That is the only difference is we consider the initial universe as the collection of all Neutrosophic set. That is, F is a function from A to U of x. That is, each element of this set is characterized by 3 components. Then it is called Neutrosophic subset. The notation n SS of x represent Neutrosophic subset. Next definition. What do you mean by the subset of Neutrosophic subset? That means, first of all, we consider FA and GB two Neutrosophic sets. Then FA is said to be a Neutrosophic subset of GB if A is a subset of B. It satisfies these inequalities. The complement is exactly same as the Neutrosophic subset. Next, the union of two Neutrosophic set FA and GB is denoted as another Neutrosophic subset. That is, T, I, F are its Neutrosophic components. It is defined as it is T, F of E of x if E belongs to A minus B. T, G of E if E belongs to B minus A. If we take maximum of this one, if E belongs to A intersection B. I means it is exactly same as T. F is F of E of x. The same if E belongs to B minus A. But only one difference, if E belongs to A intersection B, we take the minimum. Next, the intersection of two Neutrosophic subset H of C is defined as T, I and H is like this. Next, we are going to the next definition. A Neutrosophic subset is completely and uniquely characterized by a matrix form like this, and alpha ij is equal to 4 by 3. This matrix is constructed from the last example we already discussed. Next definition. let E is equal to E1, E2, En be a set of parameters in relation to the objects in X. Then A is a subset of E. Let alpha and beta are two neutrosophic subsets. It is denoted by the three components. Then one important condition is the neutrosophic components are not a scalar multiple of each other. Next, the normalized orthogonal distance between alpha and beta belongs to neutrosophic soft subset of X can be denoted as d perp of alpha beta is equal to summation I varies from 1 to m, j is equal to 1 to m square root of t alpha beta the whole square plus I b alpha beta the whole square plus gamma alpha beta the whole square divided by maximization of this one. It is for normalization, where t alpha beta can be defined as like this, I alpha beta can be defined like this, and gamma of alpha beta is equal to Fe into Tg minus Tf into Fg, where mod of f of Ej and modulus of g of j is the modulus value of this ones. Next, the normalized orthogonal distance d perp of alpha beta between alpha and beta satisfies the following properties. That is, d perp of alpha beta greater than or equal to 0. If alpha is equal to beta, its distance is 0. If it is commutative property is satisfied, then it satisfies the triangle inequality. Next, we are going to a similarity measure. A similarity measure is a real valued function which satisfies the following properties. The first one, s of ab belongs to closed interval 0, 1. If it is equal to 1, if and only if a equal to b, it satisfies the commutative property. Next, one of the important property, a subset of b subset of c implies s of ac less than or equal to minimum of s of ab comma s of bc. Next, a real valued function which is defined as S transpose of alpha beta is equal to 1 by 1 plus d perp of alpha beta is a similarity measure. Next, weighted similarity measure. The weighted similarity measure means we assign a weight for each parameters and satisfies the property summation I is equal to 1 to m, wi is equal to 1. Then ws transpose of alpha beta can be defined as 1 by 1 plus summation I is equal to 1 to m, j is equal to 1 to m, wj, then the wi into d perp of alpha beta. Next definition, the weighted similarity measure using normalized orthogonal distance between two neutrosophic sets alpha and beta satisfying these following properties. Next, an algorithm for decision in neutrosophic soft environment. The first step is develop a model for the decision making. Step 2, define the weight Wj for each criterion. Step 3, derive a model synthesis, that is, construct a decision matrix. Step 4, calculate the ideal attribute alpha j using the evaluation of each attribute aj on each criteria cj. Step 5, calculate weighted similarity measure. Step 6, determine the ranking order of all alternatives corresponding to each criterion using the relation ai star is equal to summation j is equal to 1 to n ws perp of ai comma alpha j. Next, decision making procedure in detail. Suppose we consider a decision making problem of best radiotherapy treatment for tumor cells in movable organs like lungs or chest walls in oncology. Suppose we consider a set X that contains 4 treatment methods. We denote as X1, that is a target tracking treatment in cyberknife. Cyberknife is a machine, it's a robotic manipulator. The second one, automatic breath control device, ABC. The third one is cone beam computerized tomography, that is CBCT. We are applying the 3-dimensional radiation method. Fourth one, fluoroportal imaging. We are applying only 2-dimensional method in this case. The oncologist must take a decision according to 3 criteria of parameters E is equal to E1, E2, E3, where E1 is equal to dosimetry, E2 is the prognosis, third one is environmental impact. Dosimetry is the physical condition of the patient, prognosis is the adaptation or the subdivision of the radiation acceptance of a patient. The third one, environmental impact. Next, a decision making procedure in step 2. That is, in the above mentioned criteria, E1 and E2 are the benefit criteria for the patient, E3 is the cost criteria. Then the Wj, we are saying each weight 0.35, 0.25 and 0.40 for each criteria given by analytical hierarchy process of experts in decision making. These alternatives are evaluated under the available criteria in Neutrosophic soft decision matrix. D is equal to Aij is constructed as follows. Next, from the above data, we construct the ideal attribute using the relation. For the benefit criteria, we take the first two components are maximum, the third one is minimum. For the cost criteria, it is minimum the first, the last two are maximum. Then from using that relation, we construct alpha j is equal to alpha 1, alpha 2, alpha 3 like this matrix. Next, decision making procedure in step 4, that is calculate the weighted similarity measure between the alternatives and criteria using the following result. Ws transpose of xi comma alpha j equal to 1 by 1 plus summation j is equal to 1 to n wj d perp of xi alpha j. Then using the above result, we can calculate the distance and similarity measure and weighted similarity measure of each criteria. That the first table reveals the calculation of weighted similarity measure using the criteria C1. Then second table, calculation of weighted similarity measure using the criteria C2. The third table, calculation of weighted similarity measure using C3. From this table, a final decision based on model synthesis using the relation AI star we already mentioned. Then the calculations are x1 star, x2 star and x3 star and x4 like this. From this one we can also deduce x2 star greater than x1 x1 star greater than x3 greater than x4 star. Then the decision making procedure in step 5, that is we identify the ranking order. That is the ranking order of attribute is x1 is 2, x2 is equal to 1, x3 is equal to 3 and x4 is equal to 4. So it can be concluded that the best choice of attribute is x2. So the final decision is the best radiotherapy treatment method is automatic breath control device or ABC. Next, the references are like this. The first one, Paul Isaac and Pearly P on intuitionistic fuzzy submodules of module. The second, Maji and P.K. Bishwa. The last one, vector similarity measure of simplified Neutrosophic sets and their applications. Thank you.